Hello and welcome. I am Mr. Murphy, and in this video we're going to be continuing where we left off in the previous one. We're still looking at power standard skill number 20, and in this particular power standard, again, we're looking at multiplying and dividing, dividing, and simplifying algebraic expressions dealing with rational exponents. And in the previous video we focused on the multiplying of rational expressions, and today we're going to look at, or in this video we're going to look at dividing expressions dealing with rational exponents. So to begin with, I just want to review again what is a rational exponent, even though that might be fresh in your mind from the last video, but just in case, let's make sure we understand what we're working with here. A rational exponent is where we have an exponent that's a fraction. Remember, we have a couple of parts that we're working with here. We have the base, that's the item that's sitting on the ground, and then we have the exponent up in the air. So when we're dealing with a rational exponent, or a fraction that's an exponent, we also have a numerator and denominator. And the denominator represents the root, and the numerator represents the exponent. So like we talked about before, if we have x being raised to the 2/3 power, that means that we would represent that, or we could refer to that as the third root of x being squared. Now, in this video, we're looking at dividing algebraic expressions dealing with rational exponents. And so we need to make sure that we understand what this quotient of a power theorem is all about. What that tells us is if we divide and the bases are the same, that means we need to subtract the exponents. Now, it's an excellent question to ask, and it comes up all the time. Why is it that we subtract the exponents? Well, let's take a minute and let's look at an example that will illustrate this for us. Like, for example, let's say if we had x to the 5th power divided by x squared. Well, think about what this really means. X to the 5th power means that we have x being multiplied times itself 5 times. If we have x squared, that means we have x being multiplied by itself 2 times. Well, if I go to simplify this, for every x on top, I can take away 1 from the bottom. Well, after crossing out 2 of them here, I run out of x's on the bottom, so I'm left with x times x times x, or x cubed. So another way to look at this is, since we have the bases are the same, if we subtract the exponents, 5 minus 2 would give me 3, so we would be left with x cubed. So that's how we use the quotient of powers theorem. So let's look at a couple of examples here. Now, dividing, we still divide the 15 divided by 3 normally. So 15 divided by 3 is going to be just 5. But now with my variables, I'm going to subtract the exponents. So I would have 4/5 minus 2/5. And just like adding fractions, when we subtract fractions, we need to make sure that the denominators are the same. And they both are. They both have a common denominator of 5. So I can subtract these. The numerators, 4 minus 2 would be 2. So our answer here would be 5x to the 2/5 power. Because 4 minus 2 would be 2. We leave the denominators the same. So we would have 5x to the 2/5 as our answer. Let's look at another example. Here we have negative 12 divided by 6. Well, negative 12 divided by 6 is just 2, negative 2. And our bases are the same here for the x's and the y's, so we're going to subtract these exponents. So for the x, we would have to the 2/3 power minus the 1/4 power. For the y, we're going to take 3 minus 5. But the problem is, for the x's, the rational exponents there, the fractions, do not have a common denominator. So we have to make these so they do have a common denominator. So I'm going to change that to be, instead of having a denominator of 3 or a denominator of 4, both 3 and 4 divide into 12 evenly, so I'm going to use a common denominator of 12 here. And 4 times 3 is 12, so we're going to take 2 times 4 and get 8. So we would have 8/12. So just double check and make sure that reduces to be 2/3, and sure enough, that would reduce to be 2/3, so far so good. And let's go to the 1/4. We want to have a common denominator there of 12 as well. And since 4 times 3 is 12, I take 1 times 3. So I have a fraction here of 3/12, and sure enough, that reduces to 1/4. So I know I'm doing that right. Let's just go ahead and work on this y. We have 3 minus 5, and 3 minus 5 would be negative 2. So our final answer would be, well, the 8/12 minus 3/12 would be 5/12. And then we'd have y to the negative second power. And that would be your answer. So why don't you guys take a minute and work on these two examples. So why don't you try these out, and so pause the video and hit play when you're ready to check your answer. Okay, so let's see how you did here. So again, 16 divided by 2, that just simplifies to be 8. The x's, I take 5/8 minus 3/8. Well, 5/8 minus 3/8 is going to be 2/8. And for the y, I don't know if this got you hung up at all, but this would be the same as 1, or we want to have a common denominator here, so I'm going to use this as 3/3. So when I take 4/3 minus 3/3, I have negative 1/3. Now if you notice that x, that fraction, that 2/8, can be reduced, so really you should have had this as your answer. 8x to the 1/4 power times y to the negative 1/3 power. Always make sure that if you're dealing with fractions, whether they're exponents or bases, that you reduce them when possible. Okay, let's look at how you did on this next one. Negative 24 divided by a negative 6 would be a positive 4. And looking at the x's, they have the common denominator there of 3. So 2/3 minus 4/3 would be negative 2/3. And with the y, again, that's an exponent of 1, which you can look at that as being, since we have a 1/5 in the denominator, that's the same as 5/5. So now we have a common denominator. 5/5 minus 1/5 would be 4/5. There's no reducing that we can do there. The negative 2/3 can't be reduced. The 4/5 can't be reduced. So that would be your answer. Well, there you have it. That is Power Standard skill number 20. Hopefully now you understand how to do both the multiplying and dividing of algebraic expressions dealing with rational exponents. And with that, good luck.